Welcome back to Obsession Engineering for another instalment of Franco's Fireblade. It's Sunday afternoon and I thought I'd best come in and do a little bit of overtime because on Tuesday this is going back to Honda Racing at Louth to be mapped and set up on the dyno, and it isn't really ready yet. So I better get cracking and do some more work. Today's priority jobs are to make the bike go and stop. Now, all the electronics are on, so there's no reason this won't work when I get round to plugging a laptop into it, but I'm not doing that today because I didn't bring my laptop with me. What I'm going to do today is put the correct chain and sprockets on it so that it actually has some drive from the engine. That is always going to be useful. Then I'm going to fit some brake lines because if you can go, you probably want to be able to stop. Not vital on the dyno, but it will be vital not long afterwards when we try and ride the bike. Standard gearing on the Fireblade is 16/43 with a 525 chain. For racing we're converting to a 520 chain because it's narrower, so you get less drag, so you get more power. I've ordered a selection of different sprockets, but not all of them have turned up so far. So for now I'm going to go 15 fronts and 1 tooth smaller, but I'm going to go 41 rear. So our overall ratio is only really the equivalent of about half a tooth different to the road gearing, but that'll be absolutely fine for the dyno. So I have a front sprocket fitted and I've drilled a hole through the bolt and lock wired it to the sprocket. It's probably not really necessary, but I just like having that extra security knowing the bolt is definitely not going to come out. To make life easier in future, I've also fitted some captive Spider wheel spacers, so there's one in that side, one in the other, and I've also fitted the Spider rear caliper captive bracket so that the caliper doesn't move and fall off when we're doing wheel changes. And the last little bit is I've filed a chamfer on the leading edge of the pads so that when we put the wheel in, it's a bit easier for it to feed into the brake pads. It's just little details that make changing a back wheel considerably easier. When it comes to riveting chains, most chains used to have solid end links like this. So what you needed was what I called the whale tool, and it was basically a big hammery thing to rivet them together, and it just flared the ends over like this, it just pinned them over. But now everybody is using these hollow end links like this, and the idea with this is instead of pinning it over that way, what you do is you put a piece in there and it actually flares the end up, it sort of bends it over and mushrooms it so it can't come off. Now, it does take a little bit more doing, but it does mean I got to buy a new tool. And this down here is the tool for doing it. So you use this plate first, and this plate pushes the end link on, and it pushes it on the exact amount, so the rivets stick out the exact amount and you don't crush the O-rings. And then what you do is you take that bit away and this piece here goes in, and as you can see on the end there, the pin in the middle goes inside and it actually flares the link over. So it takes a little bit more doing and it means I don't get to use my hammer, which is disappointing, but it does do a lovely job without putting as much stress on the chain. So you can see with this link now, this one I've not done anything with yet, so that is the correct size for the link to slide over the end. This one I've flared out already, so you can just see where it's sort of mushroomed the end over so that this plate can't come off. So what I need to do next is rivet that one up, and then we're job done. Chain and sprockets are fitted, and I've refitted the chain guard round here just as a security measure. If we ever broke a chain and threw it this way, it wouldn't go hopefully straight through the crankcases, so giving it a bit of safety. I may at some point actually put the sprocket cover back on because apparently it's better for aerodynamics, but that's a trick for later. A couple of extra little tricks I've done here is I've drilled and lock wired the spindle to the adjuster block so that when you're putting the wheel back in, all of this stays in the same place and it's easier to get the spindle in correctly. And the final thing, I've made a little point for the end of the spindle out of nylon, just so when you're tapping the spindle through, it finds its way into the hole easier. And it's always useful to find your way to the hole easily. When you're building a bike, you have the opportunity to do it fast, or to do all the little detail bits and do it right. So this has taken a little bit longer, but in pit lane, in the middle of qualifying when we're chucking a rear tyre in the bike and Franco needs to get out for one, hopefully, pole position qualifying lap, this is the kind of thing that can just save you a few seconds, get you back on track, and might win you a race. So now that the bike's one step closer to actually going, we need to make it one step closer to stopping. So I'm going to put some brake lines on it, and we're going to be running from the rear master cylinder down to the caliper. I'm going to do the rear one first because on the dyno, the rear brake might actually get used. We have actually got a thumb brake to go on the bike, but we don't yet have a thumb brake line, so we're going to start with the foot brake. And when we go testing, we're going to test him with the foot brake and the thumb brake and see which one he prefers anyway, so I need to make sure this works. So that is rear brake line work, and we have a nice stiff lever. Normally fitting a rear brake line is really quick. This one did take a little bit longer because the routing of the brake cable, the brake line, I could have inside or outside the main feed line, but it fits better there. But then it touched the swinging arm, so I've made a little bit of cable tie with a bit of pipe underneath it to hold it to the master cylinder so it holds it away from the swinging arm at that point. Obviously, further down the swinging arm underneath the exhaust pipe sort of area, it is P-clipped to the bottom of the swinging arm down here where there's a normal connection point. And then, of course, we came to actually bleeding the back brake. The bleed nipple's at the bottom of the caliper because these calipers are also designed to run the other way up. So I had to take the caliper off, turn it the other way up so I could get the air out of the caliper. So it did take a few minutes longer than normal, but we do now have a working back brake. And I will put money on it that he'll ride this one and then say he wants a thumb brake. Because riders are like that. They like to generate work for mechanics. That leaves me with just about enough time to put the front brake lines on, which means I need to put the calipers back on and hopefully get them bled up before I need to go for my tasty Sunday dinner. That's our basic brake line routing. So down to here, the split has to be above the bottom of the yoke for ACU regulations, and basically it means if the mudguard gets ripped off the bike, it can't take the brake line with it. So that's the logic to that, so that's going to run down there. I prefer to run brake lines around the outside of fork legs because it keeps them again out the way of the wheel and the mudguard. Down to the caliper on that side. The other side though is slightly different. The other side has this bit sticking up, and this bit will go to the brake pressure sensor to our data logger, but we haven't got it yet, so at the moment we've just got a plug in the end, but that's loose because when I start putting fluid in I'll have to bleed the air out of that little piece of pipe. Because this is a race bike and we are cutting no corners, we are using Motul RBF 700 brake fluid. So this boils at 700 degrees Fahrenheit, which I'm told is quite warm. So that is going in there. I just need to bleed it up, and hopefully before long we will have a really good front brake. One of the things I really like about radial master cylinders is that they've got a bleed nipple that's basically the highest point on the brake system, ignoring the reservoir. And the advantage of that is when you pump the brake, as you pump it in and out, it actually moves the air back up the brake lines into the master cylinder. So assuming you don't have to fill the calipers completely with fluid, which luckily on this we don't because they were already full, all we've had to do is really get the fluid from the master cylinder to pump fluid into the brake lines, and that's displaced the air, and the air bit by bit is pulled back up the brake lines into the master cylinder, and I've been able to bleed the entire system so far with just the master cylinder and this little connector here. And what I've been doing with this is just taking the top off it, and literally the weight of the fluid, because the level of the fluid is above this, has been forcing the air that's trapped in here just along here, and bit by bit it's been popping little air bubbles out of the top of here, and when there's no more air bubbles and it's just fluid in there, I've just nipped the top back up. So I've got most of the brake bleeding done without even having to touch the calipers so far, which is brilliant. I am going to have to finish them off at the calipers, but I'm not going to do that tonight. For tonight, what I'm going to do is leave the brake tied on a little bit, so that will allow some of the fluid that's in the lines just to potter back up into the sort of this section of the master cylinder, and then tomorrow it should be even quicker. I've got the chain and sprockets on, I've got brakes that work at both ends, although the front does need a little bit more attention, so it's another step closer to the Fireblade being ready to go on track, or in this case, on the dyno. In less than 24 hours, I'm supposed to be at Honda Racing in Louth to get this bike on the dyno, get it mapped and see what power it really makes. But there are still a few jobs to do before then. Yesterday I got most of the way through bleeding the brakes, so I'm going to finish bleeding the front brakes up, and then I'm going to move on to the stuff that's actually critical for the dyno. I'm going to drop the oil out of it. I have some HRC clutch parts to fit, so they're going in. Then I can put some fancy Motul, really expensive oil in it, and put some water in it so we can run it up to temperature. And I've also got a map to put in it that's been sent to me from Honda that has John McGuinness in the title. So yesterday I did most of the brake bleeding, and I have got most of a brake lever. So there's not much air left in it, but I'm going to do another little bleed just from the master cylinder to get any last little bits out the top of the system, and then I'm going to do a little run down to each caliper and just bleed any last little bits out the calipers and make sure we've then got the fancy Motul RBF 700 all the way through the system and in the calipers as well. After not too much pumping, I have a nice firm lever in my hand. Nice. So what I'm going to do to tie the brake line to the fork leg is a little piece of fuel pipe, fuel hose, a little bit of rubber pipe, that's all that is, and a cable tie. So slide the cable tie through the rubber pipe to begin with, then I'm going to slide it round the fork leg, round the brake line, back through the rubber pipe, so those two ends are tied together like that, and then if I pass that round the fork leg, just like that, tighten that up, and I now have my brake line tied away from the fork leg so it's not going to rub, and I can rearrange them when I get the bodywork on to miss anything inside the bodywork, and it just neatens the job up a little bit, holds the brake line nice and secure, nothing's rubbing on anything, job done. With the brake lines now secured and the traction control sensor line tied to that brake line, I'm happy that the brakes are finished. So I've taken the sump plug out and letting what is annoyingly clean oil drain into my bowl. The next thing I need to do is take the clutch cover off and fit our HRC kit clutch pack. So clutch cover removed, and the good news is they've got these sort of thin, almost metal gaskets on them. So as opposed to sort of like the graphite-y, papery gaskets that quite a lot of the manufacturers use, that's actually basically really thin aluminium, and it means they're reusable. So that is making life easier. Right, to remove the rest of the clutch, all I need to do is remove these 3 bolts that hold the clutch springs in place, and then everything can just slide out the front. Now the hub and everything stays in, and so does the basket, and all I need to do is change the plates and the springs. And you can see on the back of the pressure plate these 3 big ramps, and in effect these are the slipper mechanism. So when the clutch is trying to go the wrong way, these ramps push upwards against the hub, and they push the pressure plate away from the rest of the clutch and basically let the clutch slip a little bit. Right, and that is a full stack of friction and steel plates out. The back one and the front one are a different colour to ones in the middle, because these run half on the steel of the steel plate and half on the aluminium of the actual backing of the clutch and the pressure plate. So if you're putting a new clutch in, always make sure you get your plates the right way round, otherwise you will get more clutch wear. So to replace our standard clutch pack is an HRC clutch pack. What the difference is? I don't actually know. But what I am going to do is measure this one and measure a standard one and see if the thickness of the stack is different. So, standard clutch stack with my verniers, or as some people will call them, my very nears, 48.96 millimetres. So now I need to measure my HRC clutch, see what that is. The good news is this has come pre-oiled. Because it's a wet clutch, you have to wet the clutch plates before you build it all up, so that the plates can absorb any oil they want to absorb, and then they sort of swell up to the right size. How much that actually makes in practice difference, I'm not entirely sure, but it is always good practice. So 48.96 was the standard clutch, and the HRC kit is 49.4mm. So in effect it's just over 0.4 of a mil thicker with this pack than the standard one. So in theory the standard one might actually slip more on the slipper clutch, but this one will grip more when it's driving, probably. So the other difference with this clutch as well is the dark coloured clutch plates, where the original had one at the front and one at the back, this one's got 4 of them. So they're probably the difference in height. So the rebuild is pretty simple. I have my HRC anti-judder plate, which as far as I can tell is the same as a normal one, because I've measured it and I've looked at it and I can't tell any difference, but it must be ever so slightly different. So that goes in first, and then I can stack all of these inside there. Along with the clutch pack there is also HRC clutch springs, and they've got a little bit of white paint on them, whereas the standard ones have a bit of blue on them. So that's obviously the expensive difference. So I shall slot them together, get my clutch cover back on, and then I can think about putting some posh oil in it. With the clutch going in, I decided it was a good opportunity to put the GB Racing engine covers on. These are my preferred engine covers because they look nicer than the alternatives and they're nice and sturdy in a crash, so they are a proper thing and we have to have them for the rules. I've also been doing a little bit of prep for lock wiring, so I've drilled a hole through there, and the inspection cover under here, which I've now covered up, we've got an HRC one that's pre-drilled for lock wire, and I've lock wired it down to this bolt down here. I've also modified the dipstick. So according to the kit manual, we don't want to use that as our high level mark. That is now our low level mark, and our high level mark is now here, 27mm from this bottom one. So basically you run the bike with more oil in it when you're racing it. So we now have a mark here. I've done a little H line and centre popped it on both sides so we can see it. So that can go back in the hole, although there's no point in me tightening up, because of course I need to take it out to check the oil level in a minute. We also have an HRC sump plug. So it is a near enough standard sump plug with a hole drilled in it. The aluminium washer is not HRC part, you'll be pleased to know. We do also have an HRC filler cap, which is that filler cap with a hole drilled in it, in an HRC bag. The next thing to do is put some oil in the Fireblade, and we've got this special Motul 300V. I've been using Motul in all my bikes for years because I think it is the best oil you can get, and if you're racing a Honda CBR1000rr-r, then you actually have to have this 300V. Basically, this has been developed with Honda and is specified in the HRC kit manual as the only oil to run. And it isn't just normal 300V. This is 2376H Racing Kit Oil 030. What we're told from Honda is, because of the really quite snug piston to bore clearances inside these bikes, you have to run this because it's got a higher moly content than normal oil, otherwise it seizes the piston to the bores. It can't be too much of a problem because the road bikes don't require this fancy oil, but we are definitely going to be running this because it is recommended by Honda. I will admit this special oil is quite expensive. If you want to buy some, it's over £160 retail. Luckily for us, Motul have come on board and they're sponsoring us this year. So thank you very much to Motul, and it's another reason to use the best oil you can. I've set the oil level and I've also refilled with water. And when I say water, it's still February and it is going to get cold overnights occasionally, so it has got some antifreeze in it. Before we go racing, it will be drained and flushed through and filled with water, but for now, antifreeze gives us a bit of a safety margin in case it gets really, really cold. With the engine side of things actually now complete, what I need to do is plug a laptop into it and put the software in it. So in preparation for trying to start a motorcycle, of which I'm a little bit daunted because it's the first time I've actually had to plug the electronics into it, I've refitted the tank and I've connected the battery up. I have not turned the ignition switch on yet. I'm not quite brave enough for that right now. So I need to open the HRC data setting tool software. Earlier on in the build, when we were putting the wiring in, me and Pete both commented that there's a lot of connectors, but luckily nowadays you can't really plug the wrong thing into the wrong connector. Turns out you can, and the connectors from both switch gears, left and right, are the same, and I'd got them plugged the wrong way round. So when I turned the ignition switch on, nothing happened. But now it does happen. So we will open the HRC data setting tool software again. Communication start, switch is off. Okay. Now I have to turn the power on. Right, the nice thing is it already knows what year it is. 2022 bike, RRS, it's a CBR1000rr-r, calls it an ST. I think that's the Japanese version of SP, because even the software kit manual calls it ST, not SP. Right, this is all looking reasonably correct, but before I press one of the 3 buttons at the bottom, I am just going to go back into the manual and check I'm pressing the right button, because I don't want to make a mistake at this stage. This is all written in computery people language, and I am not a computery person. And this is where I can load my John McGuinness map, when I can find it. And now we can go in and change all of the settings and completely mess everything up if we really want to. How exciting! So now that I have this communicating with the bike, what I can do is I can go in and we've got, basically that's the fuel injection map 1 and map 2, so you can have 2 different maps. If I want, I can have it in 3D mode. That looks exciting. So we've also got a cylinder adjustment option, which by the look of it don't use, and then we've got different modes. So we've got injector ratios, ignition maps, ignition modes, power modes, and there's a variety of power modes. Then we've got throttle grip adjustment, and that's basically altering how quickly you open the throttle to how quickly it actually opens the throttles in the bike. There's anti-jerk stuff, which is basically how much it softens off the throttle when you first open it. Then we've got engine braking modes, engine brake skid mode, which is how much it'll allow the back wheel to actually lock up on the way into things. Engine brake something else mode. I have read most of the manual, but it does get quite complicated. Right, and then there's traction control mode, traction control offset level, traction control effect level, traction control slip target offset, slip ratio control mode, slip ratio control trigger, slip ratio control base setting, wheelie mode, shift control, and as you can see down here, a massive supply of other things that are going on. So I can go into the sprocket one, and we're not on that, we're on 1541, so we'll save that. So yes, other than changing the gearing that it's on, I'm currently not going to do anything at all until I've been to see the boys at Honda tomorrow and let them actually check it all on the dyno. The next thing to do, I think, is see if we can get this to actually start. So let's see if it'll start, because that would be kind of useful. Right, that doesn't start. Why doesn't that start? The joys of problem solving a system that you don't have a drawing for, but I now have the right connectors connected into the right places, and actually the wiring loom all tucks in a bit better, so it should have been obvious, but it wasn't. Right, moving on, I have reattached the clutch switch, because in our excitement with the wiring, we'd ended up with it disconnected. So, the bike is currently not knowing what gear it's in, which is a bit odd, because if I push down on the gear lever a little bit like that, it all of a sudden sees neutral, but it doesn't when it's sat stationary, so I need to have a fiddle with that in a minute. But until then, I should be able to start it in gear. So in fact, I'm going to dog it into first, and then it should start with the clutch pulled in. So clutch in. And it's alive! Alive, I tell you! So now I'll see if we can find neutral. No, neutral's still a bit of a mystery. Third, fourth, fifth, sixth. So we have a complement of other gears, but I must have one of the gear selectors in the wrong place, because it is currently in neutral, but it doesn't know it's in neutral. So I'll just let it get a bit of oil around itself so I can reset the oil level, and then I shall have a bit of an investigation into why it's playing up. To add a level of confusion to my general confusion, there is a gear position sensor down that side of the engine, and then there's these three connectors on top of the engine, which appear to be neutral like switches, except of course they're not. So that one I think is the one that maybe does neutral, but I've basically swapped that one round, and now we have neutral in neutral. But it's a little bit confusing because when you lay the looming, that piece of wire is perfectly the right length to go to there. But it turns out if I hook it back on itself and connect to there, it's fine, and then that goes to there. And so it does all sort of fit, but a bit like the wiring up here, it can fit the wrong way around as well. Anyway, we now have neutral in neutral, so I'm going to double check the oil and water levels, and then we'll see if we can get a bit more running. Oil and water topped up. We now have a neutral light, which is always a bonus, so that means we should run a little bit easier. Which we do. Right, I shall run us up to temperature and then double check the fluids again. Right, while the bike is cooling down, there is of course a few extra little jobs I can do. Probably put some sort of grip on both of the handlebars, that would be useful, and I do have some spider lock stops that can go on it as well. So this little machined bit here, which is surprisingly intricate and delicate looking, is going to mount, if we can see it, basically on a bolt that's behind there, onto that bolt there, and that will reduce my lock stop. This is possibly the most elegant lock stop I've ever seen. I like this spider stuff, it's nice. So I fitted some Renthal grips, I fitted his monogrammed lever guard, that's from Spider as well, and that's lovely. The lock stops that you can barely see around there are fitted, so that is excellent. I've bolted the tank down properly, and I've tidied a little bit of the wiring a bit around here so it all tucks in a little bit nicer. After all, if the boys from Honda are going to see my handiwork, I don't want it to look rough. I've also done a final last check of the fluid levels, checked the rear tyre pressure, ready for the dyno, and that is about it. So that's another day in the workshop complete, and it's been pretty good because the bike now actually runs, which is always a bit of a bonus. So the next thing I need to do is chuck that in the van and head to the dyno. None of this build or the racing that's going to follow would be possible without the Marvel HCL Motorsports team. If you would like to join the team, please drop us an email on the contact details in the comment section, and we will find a wonderful way to get you involved. Thank you for watching, and join me again next time for some more motorbike fun.